All right, so this is the second recording for this lesson 20, and hopefully by now I have mentioned to you in class that this is going to count as the summative assessment. What an easy way to get a 3 or even a 4 on the final test for the year. All right, so moving along. This is the page that we ended on in the last video. So I just want to remind everybody that what we did here for this problem about Dario borrowing $12,000 at this percent rate is we figured out what his interest would be for 1 year, what his interest would be for 5 years, and then subtracted to get our answer. All right, so let's turn over now to page 426. If you look at the model it, what they have here is a table, and they're figuring out the interest for each year. And what I'm asking is, what patterns do you notice in this table? So I'm already writing them here, so I hope you can see what happens is each year they add $504 to Dario's interest payments. All right, hopefully that makes sense if you think about it. So 504 for the first year, 504 for the second, so it gets added in. I just want to say this as an aside because this is going to be coming up. This is a linear function and it is proportional. All right. I know it's linear because it graphs to make a straight line. It's proportional because it goes through 0, 0. So that's one reason. All right. If you haven't already written it in, I'd like you to be just writing this right here. Each year you add $504. And then just this right here where it becomes clear on the table that you're adding 504 each year. Right. All right, moving along. And of course, if this is too fast for you, pause the video, right? That's the sweet thing about the video. You can pause it as needed. All right, look at this one here. All right, this is what we did. All right, we figured out the interest for 1 year was 504 using the formula. The interest for 5 was 2,520. The only thing they didn't do is the subtracting. We already did that and took care of that. All right, there's nothing that you really need to write on this page. All right, so let's turn to page 427. So it says, look at the table and the first model it. How does the interest change over time? So we can see here, it's what we said before. Each year, Dario owes $504 more in interest. So of course, I'd like you to write this answer right here under number 1. All right, please write this under number 1. All right, once you have that finished, number 2. So it says, how much more interest will Dario owe for 5 years than for 1 year? How does this difference compare to the amount of interest Dario would owe for borrowing the money for 4 years? All right, so I could have gone back to the table to look at things, but I just did this way. All right, we know it's 2016 more for 5 years. Well, I know for 4 years, because of what we said here, it's 504 less. So in the calculator, I just did 2016 minus 504, and I have 1,512. All right, so of course you don't need to do this calculator thing, but if you could please just write in this piece right here, that would be great. All right, again, pause as needed. All right, let's look at number 3 now. It says, look at the second modelet. Which values stay the same when you choose the formula to find the interest for 1 year and 5 years, and which values change? All right, so I think I pointed this out on the previous video, but it's the principal and the rate will always be the same. For Dario, it's 12,000 for the principal. The rate is always 4.2%. So the only thing that changes is the amount of time. All right, and that's really what makes it proportional. We'll talk about that later. All right, so get this answer in there for number 3. The principal and the rate remain the same. The only thing that changes is time. All right, so here's why we've been talking about this. All right, so number 4 says, how does the formula I equals PRT show a proportional relationship between simple interest and time? All right, this is a tough question. All right, so what I have here is just a review of what makes a relationship proportional. And the one I want you to focus on is right here, okay, right here, that the formula would be in the form of y equals k times x, where k is the constant of proportionality or unit rate. All right, these are the other pieces. Okay, the graph of a straight line that passes through the origin. When we looked at the graph of the relationship for Dario, we saw that that did happen. All right, we're just going to now focus on the formula. All right, a set of, or a table of ordered pairs that shows equivalent ratios. We'll talk about that later. And then a verbal description that describes a directly proportional relationship between two quantities. All right, so Ms. Bailey, what do you want us to write? Okay, so here's what I want you to write. All right, you ready? I want you, above the I equals PRT, I want you to write Y equals KX. K stands for the constant, X stands for the variable. Do you see how I've underlined the principal and the rate? That's actually going to be the constant, because since the principal and the rate never change, the K will always be the same. X is our variable and T is the variable. All right, so right here, this is what I'd like you to write. See what I'm outlining? All right, so let me read that out loud. So it says, since the principal and the rate are always the same, this amount will be constant, which means it will be the constant of proportionality. Time changes, so that would be the X variable. Really, bottom line is this matches the Y equals KX. This you don't have to write, but I just also want to say that for each of these, you multiply each of these by 504. That actually also makes it proportional. If you're always multiplying by the same number to get from one to the other, or dividing by the same number, that's also proportional. Okay, that was a bit much, but good to review proportional relationships. All right, so let's look at number 5 now. All right, now don't worry. All right, you're not going to have to write this whole thing. All right, I'll explain what I want you to write in just a minute. So it says the total amount Dario owes is the sum of the interest and the principal. Is the relationship between the total amount owed and time proportional? Explain. All right, so here's the part that I want you to write. All right, I want you to write this part here where it says no. All right, so I'm going to put a little box around the piece that should go in your packet. All right, so you can start writing this now. I know it's hard to see, it's a little blurry, but just listen to what I'm saying, all right? And I think it will help. So the answer is no. This is not proportional. 2 reasons. 1, dividing the principal plus interest by the time results in differing quotients. Okay, so what I did here was I created a table, right? Here's my principal, here's my time, here's my interest, and then here's the principal plus the interest. And then when I took the principal plus the interest divided by the time, I got different amounts over here, right? So dividing this one by this one, if I got the same amounts when I divided, it would be proportional. All right, so that's one reason. Reason 2, it does not go through 0, 0. It goes through 0, 12,000. Oops, I should add a 0 to that. Hang on just a second. All right, I'm going to add another 0 to this. All right, should be 12,000. All right, so please fix that. All right, again, this is all you need to write here, the thing that's in the red box. All right, so that's 2 reasons it's not a proportional relationship. Again, this is a little much, but good review of proportional. All right, moving along to page 428. So here's some application. It says here, Ava borrows $600 to buy a bike at a yearly simple interest rate of 2.25%. Ava borrows the money for 3 years. How much does Ava pay in simple interest, and how much does Ava pay in all? So show your work. All right, so again, you can use my work here. All right, so first thing I'd like you to do is get this part in. All right. I'm using the interest formula to determine the interest. It's $40.50. All right, so principal times rate times time. But that's not the total owed, because the total owed is right here. I had to add the original 600 plus the $40.50. So the total owed is in this box here, $640.50. All right, please get that down. And like I said, pause as needed. Okay, let's take a look at this one now, number 8. It says Zen borrows $1,200. She borrows the money for 2 years and then owes $180 in simple interest. what is the yearly simple interest rate on Zen's loan, and show your work. All right, so you can see I used a calculator, right, but I just used the formula. All right, now here is where it gets a little tricky. All right, in this case, we are going to have to solve for R. So I know what the interest is. So I put that there for interest. The principal is 1,200. I know the time is 2. I don't know what the rate is. Now I changed the order of this around just a little bit. That's okay, because it's all multiplication. So when I multiplied, I have 180 is equal to 2,400 times R. So to solve this, I really needed to divide both sides by 2,400. When I did that I got 0.075. Right, well, I'd like to change that now to an interest rate, so it's 7.5% interest. All right, that required a little bit of algebra to use. All right, so again, let's get all of this in except for the piece that's got the calculator on it. So I'd like this part written in, so I know that you're trying to write the formula down, and then of course I'd like the final answer. All right, let's look at number 9. A bank offers a savings account with a yearly simple interest rate of 2%. Suppose you deposit $550 into a savings account. How much simple interest will you earn in 4 years? And then what about in 4 years and 6 months? Show your work. All right, so you guys, I just used the formula. All right, this one is for 4 years. This one is for 4 years and 6 months. Note, I put this in as 4.5. So I would like you all to get this formula down in your notes. I guess I should call it an equation. And then get this equation down in your notes. All right, and you can see it's $44 for 4 years, $49.50 for 4.5 years, or 4 years and 6 months. All right, let's take a look next at page 429. Okay, and you can see here, there is an example. Pablo deposits $750 into a bank account. The account earns yearly simple interest at a rate of 3.5%. How many years will it take Pablo to earn a total of $105 in simple interest? All right, so they're using the formula. This time they're solving for time. So again, we're using algebra here. So you plug in what you know where it belongs. Right, so right here, the interest is 105, principal is 750, the rate is 3.5%. Note down here, we're changing it to a decimal. And since we don't know what T is, we're going to leave that as T. Remember, I have said to you before that algebra is often used for solving for the unknown. This is a case in point. We're solving for the unknown. We don't know what time is, so we leave that as a variable. All right, so then we'll do the multiplication. Okay, 105 is equal to 26.25. And then if you do 105 divided by 26.25, you get 4. So it takes 4 years. All right, we're going to use that same thing over here. All right, so this, of course, is what I want you to write right over here. So let me put just a little box around this. This is for number 1 at the bottom. And you can see I've already got the answer of 6 years. I want you to write the formula. All right, and then we're going to write in what we know, right? We know that the principal is 1,200, right? We know that the interest is 126. We know that the percentage is 1.75%. This is it as a decimal, and then we're going to solve for T. So in this case, when you multiply this out, this becomes 21. So 126 equals 21T. We want to solve for T, so we'll divide both sides by 21. You can see I did the work over here in the calculator. So T is equal to 6. So it's 6 years. All right, excellent work. This is the last one that we'll do on this video, right? You might need to pause this one to get the answers in, but right here for number 3, I'll let you read that yourself. I have put everything into the formula to get the interest. So the interest was $79.50. Note that I put 3.75 in for the years. That's because it's 3 years and 9 months. 9 out of 12 is 0.75. All right, so that's where I got this from. All right, and then I added then the principal plus the interest to get the total. All right, so right here, write everything down, but this is the answer. All right, and then right here, I'd like you just to copy everything here and get the answer in. Thank you.